Okay, so this is the question of October-November 2017. So in this question, there are two particles having the two particles that are P and Q having mass m kg. And so the first thing you have to know in this diagram, you have to draw the force acting force. So acting force you can make here R, okay, and downwards acting force is mg cos alpha. So this is mg cos alpha, okay, so this is mg cos alpha, and tension will act here, and also here is tension will act here. So this T, this will be T, and here it is given mg kg, okay, m kg means you can write mg or no need to write here, okay. So and one thing here, one force will act, that is mg sine alpha. So this is mg sine alpha. So this is mg sine alpha, okay. so you and friction will act here. So you also need to mention the friction. So friction will act here. So what is asked here? So the coefficient of friction between P and P. So you know the formula for coefficient of friction mu gives R over Fr upon R. This is Fr upon R. So you know the formula. So what you need to know, so what you need to do, you need to calculate friction and you need to calculate R. So first let's do calculate R. So R will be mg cos alpha. You can get value for cos alpha just by using Pythagoras theorem. I have already calculated. So this will be 10m times, so I have calculated for cos alpha, that is 24 over 25, and so the final answer will be 9.6 m Newton. So we have got R that is 9.6 m, and let's calculate this friction, okay. So for friction you have here Fr. So Fr, so let's do one thing. The acting force is towards pulley. So first let's do add T tension plus mg sine alpha minus this friction will give ma, and we have, like in this situation, the acceleration is 0. So what you can do here is you can do like T plus mg sine alpha gives friction, and you have got, so you need to get the value for tension. So how are you going to calculate tension? So you're going to calculate tension from this situation. So over here I'm going to show at Q. So at Q the tension will be 10m, because in this situation the acting force is mg, so tension will be what? Tension will be 10m. So you can directly place the value for 10m. So 10m plus, so mg is 10m, okay. So 10m, and sine alpha I have calculated 7 by 25. so friction. So you'll get friction value is 12.8 m Newton. Okay, so what you need to do, you need to place this 12.8 m. So the answer will be 4/3. So proved. This is very simple. So first steps, you need to uh, like write the formula for coefficient friction, that is Fr over R. And first step, let's do calculate the value of normal contact force from this situation. So, and then another one is try to find friction. So friction T here. So you need to calculate the tension from this situation. Okay. So in this question, you were asked to calculate the value of m. So previously there were unknown value for m. So in this figure you are being asked to calculate the value of m. So a force of magnitude 10 Newton is applied to P. So here an interesting thing. So over here 10 Newton is applied. So over here 10 Newton is being applied. Okay, and so acting of a line greatest slope and P accelerated at 12.5 meter per second. So acceleration also given. So you know that the friction will act its opposite side, Fr, because the opposing force is called friction, and we have already got for R, and here will be mg cos alpha. Okay, mg cos alpha, and here also another one is that is mg sine alpha. So here mg sine alpha. Okay, and tension will act to the same place. Okay, so what you were asked then, so let's see. So first thing you need to see at this Q. So for Q, let's do T is 10 m, because it's T minus 10 m equals to 2.5. We have unknown value, so this is equation 1. So I actually make one equation from this condition. So another thing, so directly tension will be 2.5 m Newton. 2.5 m Newton. So for P, so similarly for P, you know that 10 opposing force is 10 Newton. So minus friction plus we have got mg sine alpha, and also tension gives m times 2.5. okay, so from this calculation you will get value for m. You just replace this tension here. So you place this tension 12.5 m over here. So from this you'll get and we have also got a value for friction, that is in previous situation we have got 12.8 m for friction Newton. So you place this value here and you'll get m equals to 0.32. This is 0. So for m you'll get 0.327 kg.